This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to find out how the graph of a function or of a quadratic equation and its solution set are related to its graph. Now, in the previous video, you remember that we solved this equation and we got these 2 points, x is equal to -3 or x is equal to -2. Now, in this video, we want to understand what that basically means geometrically or graphically. And this is very important to understand. Otherwise, if you do everything mechanically, and well, you might be familiar with a few techniques, like for example factorization or things like that, and then you might be able to somehow get these values. But as long as you don't understand what you're doing, or it's basically like you do something but you don't know what you have done, or you don't know exactly, or it's exactly like what you found, you don't know what you can do with that. So that's basically that basically means that you don't know the concept and it just doesn't make any sense. So now we had this equation, and we found these points, and we could call them the roots of this equation. Now we want to understand what that means graphically and what the whole concept is. Now, basically any equation like this is originally an equation like, for example, y is equal to x squared plus x minus 6. And what that means is any equation that you have is essentially some relationship between two different variables that represent two different things. For example, if you have a graph like this, and let's say this graph is something like this and it goes on, and let's say this is your y-axis and this is your x-axis, and if y represents, for example, your speed of a car, and if x represents, for example, time, so then let's say this is the graph, this is the equation that created this graph. So in this case, that equation basically represents a relationship between y, which represents speed here, and x, which represents time here, of a car, for example, moving on let's say on a straight line or something like that. And so at any point in time, for example, let's say here t is equal to, or x is equal to 5, and here your units are seconds, and here your units are, for example, mile per second or something like that. So at any point in time, you can check whether, based on the graph, you can say, okay, here x is equal to 5, so that means time is equal to 5 seconds. So I can basically go up to my graph, and then this point on the graph can be mapped to this point, and this point on the y-axis gives me my speed in miles per second of this object moving on a straight line at time is equal to 5 seconds. And this you can do for every second on this axis, and then you can get the corresponding speed. So that basically means that here your y, the value of your y, depends on the value of x. Whatever the value of x you choose here, there is a corresponding value for y at that x value. And that's basically what an equation is. That equation essentially shows a relationship between x and y, and that could represent anything or any sort of situation. Now what I mean by this is, now we had this equation y is equal to x squared plus x minus 6. I can basically draw the graph of this equation, and in order to draw the graph of any equation, you already know, we have talked about that, you could do a simple table, input some values for x, and basically calculate the values of the corresponding y. For example, here to draw the graph of this equation, I could, 3 points would be enough, but let's do, for example, 5 points, and here I go 0, 1, 2, and minus 1, minus 2. Now at points x is equal to 0, this would be 0, this would be 0, so your y is minus 6. At x is equal to 1, at x is equal to 1, your y value is going to be 1 squared plus 1, so it's 2. 2 minus 6 is minus 4. At x is equal to 2, your y value is 2 squared 4. 4 plus 2 is 6. 6 minus 6 is equal to 0. At x is equal to minus 1, your y value is going to be minus 1 squared is 1. So 1 plus minus 1 is 0, so it would be minus 6. And at x is equal to minus 2, your y value is minus 2 squared is plus 4. Then 4 minus 2 is 2, and 2 minus 6 is minus 4. So now you can draw the graph of this function based on these ordered pairs. 1, 2, 3, 4, 5 points I have here. So when your x2 is 0 is 2, 0 is over here. This is 1 point. 1, minus 4 is over here. So this is another point. 0, minus 6 is over here. Minus 1, minus 6 is over here. And minus 2, minus 4 is 1, 2, 3, 4, so it comes over here. And it seems to me that now if I got another point over here, for example minus 3, let's see what minus 3 is. Minus 3 here is 9, minus 3 is 9, minus 3 is 9 minus 3 is 6. 6 minus 6 is equal to 0. So at minus 3 the y value is 0. So this would be another point, and then you could simply, this would be the graph of this function, something like this. It's not easy to draw, but I'll do my best. It's going to be something like this. Oh, sorry. So this is going to be the graph of your function, and basically these 2 points, which is, for example, this is 1, 2, 2, 0, 2, 0, and minus 3, 0 are exactly on the x-axis. There is one point here that is 1, 2, 3, 4, 5, 6. So 0, minus 6. That's exactly on the y-axis. And so as we discussed before, these are your x-intercepts. In other words, that these are the points where the function crosses the x-axis. This point 0, minus 6 is your y-intercept. This is the point where the function crosses the y-axis. And let me write y here and x here. So now if you look at the solution set that we found here, is basically I found x is equal to -3, which is this point, -3 on the x-axis, and I found x is equal to 2, which is this point over here on the x-axis. Now if I had equated in this equation, if I had equated x is equal to 0, then y would have become, y is equal to, this would have gone to 0, this would have gone to 0, and then I would have ended up with -6. And this is exactly this point over here. And if I had equated here in this equation, if I had equated y is equal to 0, so as you can see, when I equated x is equal to 0, I found the y-intercept of the function. Now by the same logic, if I equate y is equal to 0, I'm essentially finding the x-intercept. So that would become then, if here y is equal to 0, then that basically means that this whole expression is equal to 0. X squared plus x minus 6 is equal to 0, and then we would have gone through the whole process that we went through, and then I would have gotten x is equal to -3 and x is equal to 2. And then these are basically exactly, one of them is basically this point over here, and the other one is just this point over here. And as you can see in this equation, what we basically do to find the roots of the equation, are nothing but the x-intercepts over here. And the x-intercepts you find when you equate y is equal to 0. So y is equal to 0 basically means this point over here. When y is equal to 0, then you're essentially finding every point on the x-axis. So those are your x-intercepts. On the other hand, when you equate x is equal to 0, like here, what we did here, then you're basically finding the y-intercept of the function. And the x-intercepts of any function are called the roots of that function. And so that is basically the whole story of what we did in the previous video, and that's simply not very complicated, but it's essential and it's important that you understand what you're doing and what's happening behind the scenes when you, for example, find the roots of a function, what that basically geometrically or graphically means. So in the next video we are going to, let's do it right now. I think we don't have much time, but let's do it now. So for 9-1. Now, this is example number 2. Solve the quadratic equation by factoring this equation. So example number 2 says x squared plus 8x plus 15 is equal to 0. Or you know what, let's do this in the next video, because then this doesn't go with the main theme and the main subject of this video. So we'll do this example in the next video. Thank you.